Hi everyone, welcome back to Beginner-Techies. In this video, I'm going to discuss about four-sum problem. This is the variation of three-sum problem, and I have already discussed about two-sum and three-sum problem in the last couple of videos, and we have gone through with different approaches to solve those problems. Right? We discussed about the brute force, we discussed about the hashing technique, and we have seen the complexity of hashing technique. We have seen the complexity of brute force, and we discussed about the two-pointer approach. So, till three-sum problems, if we compare the complexity, so two-pointer approach would be better because we can solve this problem without using any extra space. Though we have same complexity, like in three-sum we have n square log n, right? So similar way we have to solve the four-sum problem as well. I will not discuss the hashing technique and brute force because we already know those approaches is not a better approach to solve this problem, right? This kind of problem. So I will go through the two-pointer technique only. So if you think about the three-sum solutions, already like I have the solution over here. So we just need to do some few changes into this existing code. Okay, so let us first understand the like problem statement. What is the requirement for some problem? So here an array is given. Okay, so we have to return an array of all the unique quadruplets. We have to return the all the unique quadruplets such that all the a b c d are distinct and their sum should be equal to target. So in the three-sum problem, the target was given as 0, and here the target is any like it could be any number. Okay, it's not restricted to 0, and we can return answer in any order. So order doesn't matter in this case. So the same thing we have for four-sum as well as we had for three-sum. So we in three-sum we had to calculate the triplets. Here we have to calculate the quadruplets. Okay, so let's see this example. We have this 1 0 minus 1 0 minus 2 2. So here the answer, expected answer is minus 2 minus 1 1 2. So if we sum these four numbers, okay, so yeah, so the sum will be 0. If we sum these four numbers, sum will be 0. If we sum these four numbers, sum will be 0. So the target is 0 in this case. So this is the expected output. If you see here, so the target is a. So we have these quadruplets. Only one quadruplets will be here, right? So the requirement is same. The only different is in three-sum we had we need to find out the triplets. We have to do the three-sum. Here we have to do the four-sum. Okay. So let me just draw an example over here. Let me take this example. Nums is equal to what? 1 0 minus 1 0 minus 2, right? So this is the example. Yeah. So while applying this two-pointer techniques, first we have to sort the array, right? So the sorted array will look like minus 1 0 0 1 2. This is the sorted array. Okay, so we have to find out the quadruplets, and the target is what? In this case, target is equal to 0. So here if we see minus 2 minus 1 plus so here if you see minus 2 minus 1 plus 1 plus 2 is equal to 0. So this is the expected quadruplets. So in this case the output will be what? Minus 2 minus 1 1 2. This is one expected quadruplets. If you see here minus 1 0 0 1, So the sum of these four number is what? 0. So this is another quadruplets, minus 1, 0, 0, 1, right? If you see, right, minus 2, 0, 0, 2, plus, plus, plus. So the output will be 0. So this is another expected quadruplets, right? So this is the output, this is the expected output we have got, right? These are the three quadruplets. So in each array we have these four number, right? So this is one quadruplets, right? This is one quadruplets. So the same approach we have to follow, right? So we can solve this problem with the help of two-pointer technique, right? We can apply the same approach as we had for three-sum problem, right? If we see this problem, so like as I have already discussed about the two-sum problem, in two-sum problem, I have also used two-pointer technique. With opposite direction. So in in this two-sum problem, what we did, we simply use one loop, right? We had this left pointer and we have this right pointer, and we did our calculation over here. This is for two-sum. So if we see three-sum problem, we did the same approach, but we have added one more loop over here, right? One more loop over here, and this logic will be same two-sum. So if we see about foursome, we will have what? Another loop. We have another loop, and we will keep the threesome logic over here. There is only slight variation in the logic, but the template would be the same. This way we have to solve five-sum, six-sum, right? Nth sum. So this way we can solve the problem. If we are talking about nth sum, then we have to go with recursive approach, right? So right now we are just concentrating about this foursome problem. So we can simply use the threesome logic, and we can do the slight variation into the logic, and we will get the result. So let's write the code on the lead code, and let's see what could be the possible changes in threesome logic. Okay, right. So here we have this threesome logic, sorry, threesome code over here. I will just copy this complete code, and I will add over here. Okay, sorting is required for this. This is the return result. We have to return the result here, res, and this. So here we have to add one more loop, int j is equal to 0, j less than nums dot length j plus plus. And here this should be start from j plus 1. Okay, this logic will be there, and this should be fine, this should be fine. Okay, here this should be, this bracket should be open, it should be closed over here. Okay, right. So we have to write the same thing here for this outer loop as well. It should be j. This logic will use to avoid the duplicacy. Okay, we will not check the duplicate element. To save, and here it should be nums I, nums left. So here it should be nums of what, j. Here it should be nums of j, and this sum is equal to target. We have target, right? This sum greater than target. Okay, here it should be nums of, we need to add j. Now let me run this application. Right, so the case 1 is success, then second test case is getting failed. Second test case is getting failed. Why it is failed? Oh, sorry. So this should be j plus 1. Okay, I greater than j plus 1. I think it should work now. So both the test cases are passed. Let me submit this solution. Okay, so out of 292, 291 cases are passed. Okay, so we need to handle this one as well. So before even starting our code, we can check this target value. If target is equal to what, this value, if target is equal to, so we have to return collections dot empty list, right. So let me submit this solution. Right, so it took 26 ms, right? The solution is accepted. So we have only did minimal changes with threesome logic, right? The logic is same, we just did minimal changes, slight variation in the logic, and we are able to get the results. And the complexity of this solution is, since we are using three loops, like here the first for loop, then second for loop, and here we have these two pointer, like we are moving these two pointers in opposite directions. For that we have this loop. The total three loops we are using. So n cube of n cube is the like for these three loops, and we have these sorting. So n cube plus n log n, sorting will take n log n, right? N log n. So if we calculate the complete complexity, so we will get o of n cube log n. So this is the complexity we have for this for some problem without using any extra space, right? So we will see some more problem based on two pointer technique. See you in the next video. Thank you. Bye bye.